Hi everyone, today we'll discuss one more topic in matrices, characteristic roots and vectors of a matrix or eigenvalues or eigenvector. This we are doing only for a square matrix. Please make a note. We are doing only for a square matrix. It is applicable only to the square matrix. We are A minus lambda I. Lambda is called eigenvalue. We are going to find. A minus lambda I is called characteristic matrix of given A. A mod of A minus lambda is called characteristic polynomial of A. Determinant A minus lambda I equal to 0 is called characteristic equation. With this, the roots of these characteristic equations are called eigenvalues, latent roots, or characteristics, whatever you want to call. But nowadays, they are calling eigenvalues. A minus lambda I equal to 0. With this, we are finding the value of x. Square matrix x1 x2, 3 by 3 matrix, 2 by 2 matrix x1 x2, 3 by 3 matrix x1 x3. Three eigenvalues we are finding corresponding to lambda equal to whatever. Lambda equal to one value we are finding. Lambda equal another. For square matrix, we have two eigenvalues, four eigenvectors. Like that. So let's go for a problem. It will be easy for us to understand. Find the eigenvalues and eigenvector corresponding to the largest characteristic roots or eigenvalue where A is given by this matrix. Let's start. So first we have to write A minus lambda I. What is our A? 8 minus 6, 2, minus 6, 7, minus 4, 2, minus 4, 3. Minus lambda of I. What is our I? 1, 0, 0, 0, 1, 0, 0, 0, 1. So what we have? Characteristic equation of the A minus lambda I equal to 0. So this means mod of, you see, x, only this will change. Only this will change because we have 1, 1, 1. All will be the same. So 8 minus lambda, 7 minus lambda, 3 minus lambda. Remaining elements are same. Remaining elements are same. Minus 6. Remaining elements are same. Remaining elements are same. So minus 6, 2, minus 4, minus 6, 2, minus 4. Okay. So equal to 0. Now expanding by R1. Expanding by R1. So 8 minus lambda as it is. This one. Now going this row, this column and this row. 7. So 7 minus lambda, 3 minus lambda. Minus 4 times 4 is 16. Minus times minus is plus. So it is minus 16. Minus this minus. So it become plus. This row go, this column gone. This row is gone. Minus 6 of 3 minus lambda. Minus 6 of 3 minus lambda. Minus this 8. Minus of minus plus 8. Plus 2 of this is gone. This is gone. So minus times minus plus 24 minus 2 times 7 minus lambda equal to 0. Now simplify 8 minus lambda as it is. 3 7s are 21 minus 7 lambda minus 3 lambda plus lambda square minus 60 plus 6 minus 3 6 are 18 minus into minus plus lambda plus 8 plus 2 as it is 24 minus 14 plus 2 lambda should be equal to 0. So 8 minus lambda, lambda square minus 10 lambda, 21 minus 16 is plus 5, plus 6 of 6 lambda minus 18 plus 10 is minus 10. Minus 10 plus 2 times of 2 lambda 24 minus 14 is plus 10. Plus 10 should be equal to 0. Now expanding 8 into lambda square minus 80 lambda plus 8 5 8 is a 40. Minus lambda into lambda square is lambda cube. Minus into minus plus 10 lambda square minus 5 lambda plus 36 lambda minus 60 plus 4 lambda plus 20 should be equal to 0. You see lambda cube is only 1, so I am writing lambda cube. Now we have to go for lambda square. 8 lambda square, 10 lambda square, that's it. So both are plus, so 18 lambda square, 18 lambda square. Now minus 80 lambda minus plus 36 lambda plus 4 lambda minus 5 lambda. So this is minus 80 minus 5 is minus 85. 36 plus 4 is 40. So 45 with minus sign. 45 means minus sign. So minus 45 lambda. Now minus 60. This is minus 60 plus 20 plus 40. 40 plus 20 is 60 plus 60 minus 60. Gone. Now minus lambda, if you take common, lambda square plus minus 18 lambda plus 45 should be equal to 0. Should be equal to 0. So here lambda equal to 0 or lambda square minus 18 lambda plus 45 equal to 0. You see factors of 45 is 3 into 15. 3, 5, 3, 15 3 is a 45. 15 plus 3 is 18. We want lambda. So lambda square minus 3 lambda minus 15. 15 lambda plus 45 should be equal to 0. So if we take lambda, lambda minus 3. If we take minus 15, lambda minus 3. So therefore, this will be lambda minus 3, lambda minus 15 equal to 0. Therefore, lambda equal to 3, lambda equal to 15, already lambda equal to 0. We got 3 values. What the question says? What the question says? Find the eigenvector corresponding to the largest characteristic root or eigenvalue, largest eigenvalue. So let's go. For lambda equal to 15, we have to go. Therefore, let x, y, z be the eigen vectors corresponding to lambda. Then a minus lambda, a minus lambda I of x should be equal to 0. So what is our a minus lambda I? 8 minus 15. Eigenvalue is 15. Minus 6, 2, minus 6, 7 minus lambda, minus 4, 2, minus 4, 3 minus lambda. X, Y, Z equal to 0. What is our lambda? This is the minus lambda. So lambda equal to 50. Lambda equal to 50. So our matrix reduces to 8 minus 15 is minus 7, minus 6, 2, minus 6, minus 8, minus 4, 2, minus 4, 3 minus 15 is minus 12. Minus 12. X, Y, Z, 0, 0, 0. What we are doing here, R1 implies R1 minus R2, and R3 implies R3 minus R2. So R1 minus R2, minus 7 minus plus 6. So this is minus 1, minus 6 minus of minus, it is plus 2, plus 2. This is 2 minus of minus. So 4, it is 6. This is as it is. And R2 implies R3 implies R3 by minus 2. So this is minus 1. This is minus 4, minus 4 by minus 2, it is 2. This is minus 12 by minus is plus, it is 6. 6. Now, what I am doing is R3 implies R3 minus R1, and R2 implies R2 by minus 2. So R1 as it is, R1 as it is, R3 implies R3 minus R1, and R2 implies R2 by minus R2. So 2 ones are 2 threes are 6, 2 fours are 8, 2 twos are 2 twos are 4, 2 fours are 8, 2 threes are 6. Now 1 minus 1 plus 1, it's 0, 0, 0. Okay. Now what I am doing is R2 implies R2 minus, no, plus 3R1. So R1 as it is, we are not doing anything to R1, and R3 as it is, we are not doing anything to R3. Now only operation is R2. R2. R2 minus R2 plus 3R1. 3 minus of plus 3, it is 0. 4, or 2 3s are 6. 6 plus 4 is 10. 2, 3 6 are 18, 20. Am I right? 3 plus 3 0. 4 plus 2 3s are 6. 6 plus 4 10. 6 3s are 18. 18 plus 2 20. Now equation number 1. What is the equation number 1? Minus x plus 2y plus 6z equal to 0. And another one is multiplying by minus, so it becomes plus. Another equation is 10y plus 20z equal to 0, or y plus 2z equal to 0. Y plus 2z equal to 0. Y equal to minus 2z let z equal to 1. So y equal to -2, z equal to 1. If you substitute here z equal to 1, y equal to -2, -2, -2 is -4, plus 6, minus x, this equal to 0, minus x plus 2 equal to 0, x equal to 2, x equal to 2. So therefore, corresponding eigenvector for eigenvalue lambda equal to 15 is x is 2, y is -2, z is 1. This is the value. See here, please, one more time. What we have to do, we have to find the eigenvalues and eigenvector. So what we have to do for eigenvalues? A minus mod of A minus lambda I equal to 0. Expand the determinant, find the value of the lambda. Because it is a 3 by 3 matrix, so lambda will have 3 values, 0, 3, 15. So we have to, as a rule, we have to find all, but in the question he want largest characteristic root. So largest characteristic root is lambda equal to 15. Put in this equation. In this equation, lambda equal to 15. Then find the value of xyz. Whatever xyz is they are nothing but the eigenvectors corresponding to eigenvalues. Okay. Thanks for watching. Please do subscribe my channel and share with your friends.